There's an incredible engineering secret that's been hiding in plain sight for thousands of years. It connects two objects that you'd swear have absolutely nothing in common. Let's just dive right in and take a look.
Okay, so here they are. On the left, you've got this rough grinding stone. I mean, we're talking ancient technology, right? And then on the right, you've got this super sleek, modern, precision milled piece of steel. They look like they're from completely different worlds, don't they?
So, what gives? What could these two possibly have in common? Seriously, what's the secret that ties this ancient stone to this high-tech steel? Well, that's the puzzle we're going to solve today. Let's dig in.
All right, first things first, let's take a closer look at that stone. It might look simple, just a big rock, but trust me, there's some seriously brilliant engineering going on here.
So this is a millstone. For, thousands of years, this was basically the engine of civilization, grinding grain to make flour. But the real magic, the real genius of this thing isn't just that it's heavy. No, it's hidden right there on its surface. See those grooves? They're not just for decoration. They are an incredibly clever system. They're designed to channel the grain and usually a little bit of water, which creates this kind of slurry. And that slurry, it acts like a lubricant. It allows these two enormous, heavy stones to just glide past each other, smooth as anything, instead of just grinding themselves to dust. Okay, now, let's hit the fast forward button. We're going to jump ahead a few thousand years. Welcome to the world of modern manufacturing where precision isn't just important, it's everything. What you're looking at here is the sliding surface from a high-precision machine, something like a lathe or a milling machine. The movements here have to be unbelievably smooth and accurate. We're talking about tolerances that are fractions of a millimeter. If there's even the tiniest bit of friction or stickiness, the whole part you're making is completely ruined. So how do they achieve that level of smoothness? Well, it's thanks to a principle called, get this, hydrodynamic lubrication. I know, it's a mouthful, but the idea behind it is actually super simple. You've seen a car hydroplane on a wet road, right? Where a thin layer of water lifts the tires right off the pavement? It's the exact same idea here. But instead of water, a super thin film of oil completely separates the metal surfaces. They never even touch. Okay, but how do you keep that perfect little film of oil in place? Well, take a closer look at the surface. You see those patterns? Those are not scratches. They're actually tiny, precisely scraped pockets. And each one acts like a miniature reservoir, holding onto that lubricant and making sure there's always that perfect, frictionless film of oil right where it needs to be. All right, so we've looked at the ancient stone, we've looked at the modern metal. I think it's time we bring it all together and finally reveal this timeless engineering secret. And here it is. This chart just lays it all out perfectly. The grooves on the grinding stone, the oil pockets on the machine tool, they are doing the exact same job. Both of them are using intentional patterns on a surface to hold and distribute some kind of medium. For the stone, it's a slurry of grain and water. For the machine, it's oil. But in both cases, that medium acts as a lubricant. I mean, think about it. The fundamental goal is identical. Let two heavy, flat surfaces slide past each other with practically zero friction and, maybe more importantly, stop them from tearing each other apart. It is the exact same problem, with the exact same brilliant solution, just separated by thousands of years of human ingenuity. And this is the so what. This is why it's so important. It doesn't matter if you're working with stone or steel, the benefits are the same. You get that smooth, continuous motion you need. Your machine becomes way more efficient because you're not just wasting energy fighting friction. And, of course, you protect your parts from wearing out and failing prematurely. It's a win-win-win. So it really all boils down to this one simple, powerful idea. You take a well-designed surface, you combine it with the right kind of lubrication, and that's the magic formula. That's what's critical for any machine, ancient or modern, to operate reliably and efficiently. It's incredible when you stop and think about it, isn't it? It's such a testament to human ingenuity. The very same fundamental principle that helped our ancestors make bread is now at the absolute core of the super high-tech, ultra-precise machines that build, pretty much everything in our modern world. And that really gets you thinking, doesn't it? It makes you wonder, what other amazing ancient secrets are just hiding all around us in our modern world, waiting for us to connect the dots? Something to think about. Thanks for joining me on this one.